In tonight's video, I'll be talking about the metric system. The metric system is the unit of measurement used in most places throughout the world besides the United States. It uses the meter to measure length, the gram to measure mass, and the liter to measure liquid capacity. And then it uses those three basic units with some prefixes to show different sizes. So for instance, the meter is the basic unit for distance. A decameter is 10 meters, a hectometer is 100 meters, and a kilometer is 1,000 meters. So you can see how easy it will be to convert because all you're doing is multiplying by powers of 10, or when you're getting smaller, you're dividing by powers of 10, which is really nice compared to the system we use now, which is everything is a different conversion. For instance, feet to miles is 5,280, or inches to feet is 12 inches per foot, 3 feet per yard. There's 4 quarts in a gallon and 2 cups in a pint. So there's all these different random numbers that are for conversions that you have to remember. Whereas in the metric system, you just have to know these 7 basic words and know that each one is 10 larger than the other. So this is for distance. The part in red here, right here, is the abbreviation. So just like you would abbreviate inches to be IN, kilometers are KM, hectometers are HM, decameters are DAM, and so on. And you'll notice as we switch over to the next unit of measurement, which is for weight, the gram, it's going to use the same prefixes. So kilo, hecto, deca, kilo, hecto, deca. Oops, I think that's supposed to be an A. Hectogram. We'll fix that. Alright. I think it is. Oh, maybe it is hecto. Oh, it is an O. I blew it. Okay. So that is an O. Take it all back. So the same thing applies. Again, the basic unit is 1 gram. A decagram is 10 of those. A hectogram is 10 decagrams, or 100 grams. A kilogram is 1,000 grams. And then you have the smaller ones. A decigram is 1/10 of a gram. Centigram is 1/100th of a gram. Centi, like dollars and cents, 100 cents in a dollar. There's 100 centigrams make up a gram. And then you have milligrams, which a lot of your medicines that you take and pills are in milligrams. That's a very small amount. And the next one we have is liters. That's volume. So think of the big thing in the store you get is a 2 liter. That's a 2 liter of soda. So 1 liter is quite a bit of soda. It's probably like a large that you get from a fast food place or a movie theater or something. A milliliter, that's probably like a thimbleful of liquid. It's very small. And then a kiloliter, you can imagine being 1,000 liters, so it's quite a lot. So getting to the conversions, which is very easy once you practice it a little bit. So if we want to change milliliters to liters, first we have to know how far away they are on the scale here. And notice, so we have the kiloliters is the biggest thing here, and then the milliliters is the smallest thing here. Now there are smaller and bigger prefixes, like nanoliters and things like that, but these are the most common, so that's what we're going to spend our time on. So we're changing milliliters to liters, and so milliliters are, get a different color, are 1, 2, 3 steps away from liters. So that's 3 powers of 10. So multiplying by 1,000 or dividing by 1,000. Okay, so we're basically moving the decimal 3 places here. So by moving the decimal 3 places, you might say, well, where's the decimal? Well, if the decimal isn't shown, it's always at the end of the number. So that's where we are originally. So we're going to move it 3 places. So the question is, well, what 3 places? So if we move it 3 places this way, we get 0.2 0.245. If instead we moved it 3 places this way, we would get 245,000. Okay. So rather than memorizing what we're multiplying by and which way we're going, I always try to think of it logically. So, knowing that we had to move it 3 places, what makes more sense? Well, we have a bunch of these little things. And so if we want them to be equal, do we need more big things to have the same amount? So picture 245 thimbles full. How many big containers would that fill? Would it fill 245,000 big containers, or would it fill part of a container? And since thimbles are so small, they're going to fill part of a container. So our answer is 0.245 liters. Let's do some more practice here so you can, let's see if it makes sense for you. So here we have 1.4 grams and equals some amount of milligrams. Okay, so if we go to grams, 1 gram is about the weight of a paper clip. And like I said, milligrams are very small. That's like 1,000th of a paper clip. So if you cut a paper clip into 1,000 pieces and weighed one of them, that would be a milligram. Okay, so again, we're moving 3 spots. So from gram to milligram. Let's see if we can count that. So gram, we're going 1, 2, 3. So the decimal is going to move 3 places. Well, let's see what that's going to look like. So we might move it this way. 2, 3. So we get 1,400. Or we might think, gosh, I don't know, maybe I should move it this way. 1, 2, 3. And then we'd get 0.0014. Well, milligrams are very tiny things. So in order to equal the same weight, if we had a little scale here, and here's our little fulcrum. And on this side, we have a paper clip. So what's a paper clip look like? Something like that. So there's our paper clip. And that's 1 gram, right? But we have 1.4. So it's a little over 1 paper clip. And on this side, we have little tiny pieces of paper clip. And each piece is a 1,000th of a paper clip. Are we going to need a lot of these little things or a little? Are we going to need a lot of them to equal the same weight as one of those, or just a few of them? And so logically we think, well, in order to be the same weight, we're going to need a lot of these little things, and so we need more, right? So we're going to say 1,400 milligrams. So I'm going to go on to a couple more examples. For each one of these, I recommend you pause, try it for yourself, and then resume when you're ready. So we're doing grams to kilograms. So we'll go to grams again. I'm going to erase this. So now we're going grams to kilograms. So I'm going 1, 2, 3 spots. So the decimal is going to move 3 times. So it starts out at 64.0. So we're going to move it 3. 1, 2, 3. So we might need a lot of kilograms. Or we might need a little bit. 1, 2, 3. That's 0.064. So logically, I'm thinking, well, grams compared to kilograms are very small. So we have 64 very small things. Is that going to equal 64,000 large things or heavy things? So that doesn't make sense, right? So we need part of one very heavy thing would equal, 64 very small things. So we have 0.064 kilograms is our answer. All right, let's try number 4. we're doing liters to milliliters. So I'm going to go find our liters. Here we go. I'll erase this. We're doing liters to milliliters. Oh, I guess that was the same, so I didn't need to erase it. So we're going 1, 2, 3 movements. So we have 302 milliliters. 302. Question is, do we want to get 302,000? Or do we want go the other way? 302. 0.302. Okay, and then logically, we need to say, well, 302 milliliters. Milliliters are very small things, so it's a very small amount of liquid. Is that going to equal 302,000 huge containers of liquid? That doesn't make any sense, because a lot of small things would equal less big things. So that's not correct, so we're going to circle this one. So 0.302 liters, because liters are big, so we only get part of a liter by using 302. We would need 1,000 milliliters just to get 1 liter. All right, this is a more interesting one. So we have millimeters to kilometers. So let's see where we're at here. So millimeters are way down here. Kilometers are 1, 2, 3, 4, 5, 6 movements away. 6 decimal places. So this is a lot of very small things. And this is a huge thing. So picture taking little tiny ant steps here. And then picture these as being huge, gigantic, giant cyclops steps. So how many big, huge steps would you need to take to equal all these little tiny small steps? Certainly you're going to need less huge steps to cover the same distance. So we're going to go small. We're going to go to the left. So we start with 8490, and I forgot how much we counted now. We went 1, 2, 3, 4, 5, 6. So we're going to go 1, 2, 3, 4, 5, 6. So we don't even need 1 kilometer to cover that distance. We need 0.00849. And remember, we can drop that last 0 there. Kilometers. And that's it. All right. Don't forget to fill out the form.